Hey there, welcome to this video. This is 9-6, and we're going to go ahead and finish up looking at some more types of integration problems. Okay, so let's go ahead and review some simple algebraic techniques that we have used to fit integrals into forms that we can go ahead and use other basic integration formulas with. Number one, multiplication, expansion. So if you have something to a power and you can go ahead and multiply or FOIL that out, then go ahead and do so. Step two, term by term division, dividing by a monomial. This is when you have one term in your denominator, you can go ahead and divide everything by that denominator. And that's very, very easy to integrate, term by term. Step three, whenever your power is the same in the numerator as the denominator, or the numerator is greater than the denominator, you're going to go ahead and do long division. So we'll look at an example where we do that. And then step four, splitting or separating the numerator. And the complicated or more difficult to see examples we'll cover in the next lesson. Okay, and we'll go ahead and get some practice right now. All right, so here we are, example 3. We are asked to integrate the integral of e to the power 2x minus 2 squared. Well, again, here, notice I have a power of 2. So what we're going to go ahead and do is we're going to go ahead and FOIL this out. This is e to the power of 2x minus 2 times e to the power of 2x minus 2. Okay, and we can go ahead and FOIL this out. So here we have e to the power of 4x minus 4e to the power of 2x plus 4, okay, and all of that is dx. Now that I have a polynomial, okay, I can go ahead and I can split this up. I can integrate piece by piece. So I have the integral of e to the power of 4x dx minus 4 e to the power of 2x dx plus 4 times the integral of dx. Okay, so let's go ahead and integrate these piece by piece. Notice here I have a function of 4x, so I do need that hook. I need an integral, right, to account for that hook. So I need a 4 here, so I'm going to balance it with a 1/4. Okay, and I can go ahead and integrate, and we get 1/4 e to the power of 4x. All right, because the integral of e to the x is e to the x, right? Spider-Man meme. Okay, minus, okay, I'm going to go ahead. Same thing here. I need a hook of 2, right? I need a hook of 2 to integrate that e to the x problem. So notice I have a 4 out front. So I'm going to go ahead and split that 4 to be a 2 by 2. So I have 2 times the integral of e to the power of 2x times 2 dx, right? And then there is your hook. It goes away. That's multiplication, not subtraction or a negative sign. So minus 2 e to the power of 2x, okay? And then plus 4 times the integral of dx, which is just x plus c. And there you have it. Not too bad, right? Piece by piece. All right. Let's go ahead and look at number 4. On number 4, notice, hey, I've got a monomial in my denominator. Okay, so what that means is I can go ahead and divide everything. And what I'm going to do is I'll switch all these to fractional exponent form. So negative 2x to the 1/2 plus 1 all over x to the power of 1/2. And I can go ahead and divide everything by this term, right? So this looks like the integral of x over x to the power of 1/2 minus 2x to the 1/2 over x to the 1/2, okay, plus 1 over x to the 1/2, right? And all of this is times dx. So now I'm going to go ahead and I'll just clean house. So we have the integral of x to the power of 1/2 minus 2 plus x to the power of negative 1/2. Again, all of this to dx. Okay, so I can go ahead, right, and I can integrate like this, just term by term. So this gives us x to the power of 3/2 divided by 3/2 minus 2x plus x to the power of 1/2 divided by 1/2 plus c, right? And if I just want to go ahead and clean this up, especially too if we were going to evaluate if this was a definite integral, minus 2x plus 2x to the 1/2 plus c. And there you have it. Not too bad, right? Those are the ones we hope for. We hope we can expand and integrate piece by piece, or divide by a monomial and integrate piece by piece. Okay, let's go ahead and check out some more complicated ones. All right, on number 5, we have noticed the same power in the numerator and the denominator. So what should our approach be? Well, can I factor out the denominator and numerator and go ahead and reduce things? That would be a good approach. However, in this case, we can't. So what we're going to have to go ahead and do is long division. So, and I don't know why I said it like that. So we have x squared plus x divided into x squared minus x minus 1. Okay, so we have a 1, negative 2x, negative 1. Okay, so here's our integral. So the integral of 1, okay, plus negative 2x minus 1 over x squared plus x dx. All right. Okay, so I know the first one's very, very easy. The second term, if I go ahead and what if I treat the denominator as a function of u? So x squared plus x, so then u prime would be 2x plus 1. Hey, don't I have that in the numerator? It's just I have a negative, right? So what I'm going to go ahead and do is I'll factor out the negative. So we have the integral of 1 plus, actually no plus. I'm going to take out a negative to make this a minus, and then this is 2x plus 1 over x squared plus x. And if you're wondering about the legality of that, again, I'm taking out a negative here. So I'll pull out the negative, that makes this positive, right? And then this turns this into a negative. Okay, dx. All right, and we'll go ahead and integrate. So we get x, okay, minus, so now this is really a 1 over u type, right? Natural log of the absolute value of the denominator, x squared plus x plus c. And there it is. Bonito. Okay, number 6. Ooh, number 6. Number 6 is ugly. Like, really ugly. But, let's go ahead and clean it up. Let's put some makeup on it. Number 6, I want to go back to our notes here. Okay, so number 6, this is where we're going to go ahead and step 4, we're going to split the numerator. Okay, so, and we did this in the last lesson as well. We split this to where it looks like this. So 3 over the square root of 1 minus x squared. Okay. Plus negative x over the square root of 1 minus x squared dx. So now I can go ahead and I can integrate piece by piece. Now, why in the heck did I do this? Well, if you look at the first one, really, actually, if I go ahead and move this, if I write this like this, I hope you see arc sine, right? That this is arc sine of x, okay, with the 3 out front. So 3 times arc sine of x, okay? And then what about your second part? Well, the second one, if I go ahead and I'm going to do this. I'm going to bring this up. So 1 minus x squared to the power of negative 1/2 times negative x dx. Okay, so let's talk about this. This is not arc sine, right? I have a variable in the numerator. So what I can do is I can treat my radicand as a u, 1 minus x squared. So then u prime is equal to negative 2x, right? So I already have my x, okay? I already have the x present and the negative as well. So I already have the negative and the x. I'm just missing the 2. Hey, no problem. Can't I go ahead and I'll drop in a 2 here and then balance with the 1/2. Okay? All right, so we get 3 arc sine of x plus 1/2, and now I'm just going to go ahead and integrate this power. So I'll add 1, so we get 1/2, divide by 1/2, plus c, and you're done. The 1/2's cancel, but you don't have to cancel or reduce. There's your answer. Not too bad, right? Okay, so just a note at the bottom here, they're wanting you to make sure that you don't commit an algebraic felony. You separated the numerator to create basic integration forms in example 6. Do not make this error. I can't go ahead and split a denominator, right? So 1 over x squared dx plus 1 over 1 dx. I cannot do that. I cannot. That's an algebraic felony, okay? Don't do this. All right, and if you were to integrate that, that's just arctan, right? Okay. Number 7 and 8. Here we go. All right, 7 looks super messy. Super messy. But I want you to see I have e to the cosine of 2x. So if I treat that power, cosine of 2x, as my u, okay, as a function of x, then u prime is negative sine of 2x times 2. So, hey, don't I already have the sine of 2x up front? I do. Can I drop into negative 2? I can. All right, so let's go ahead and do just that. So this is the integral of e to the power of cosine of 2x times, okay, I need, so here's my hook, times negative 2 sine of 2x dx. Okay, and I need to balance that negative 2, so I'll balance it with a negative 1/2. All right, and what is the integral of e to the x? E to the x. Ta-da! Not too bad, right? Not too bad. Okay, number 8, last one. All right, on number 8, man, I see trig, but most importantly, what I see in the denominator is something squared plus something squared, and this just is screaming arctan type, right? Where u is tan of x and a is 3. Okay, I see that, but the secant squared is a problem. Well, I mean, if I let u is my function, I have to have a u prime. And let me see, what is the derivative of tan of x? What'd you say? Oh, it's secant squared? Ah, check that out. So I already have a u prime. Okay, so this is just arctan. Not bad at all. Okay, so I'm going to go ahead and rewrite this as 1 over tan squared x plus 9. Okay, and then our hook, right, secant squared x dx, that's going to go away. Okay, so this is, remember, integral for arctan is 1 over a, so 1/3 arctan of u over a, so tan x over 3 plus c. Boom, we're done. All right. Okay, so lots of integration formulas. Remember the formulas, lots and lots of practice. You'll be fine. Inch by inch, math is a cinch. Yard by yard, math is very hard. That's some wisdom. Mic drop. Catch you next time. Peace.